Hello, everyone, and welcome to episode 5 of our series called Software Package Deconstruction, Assessing Risks to Your Software Supply Chain. Each episode, we deconstruct a software package and do a deep dive into its risk profile to better understand its unique attack vector. And we hope that in some small way, we can enable your security team to stay one step ahead of malicious actors. We'll start with a little housekeeping. If you have any questions or comments, please submit them through the Q&A feature on Zoom webinar. We're recording this episode for those who can't attend live, and you'll be able to find it on our website's media pages shortly after the conclusion of today's webinar. After the webinar, we'll also be sending out a follow-up email to all registrants with any relevant links we think you might find useful, as well as a link to the aforementioned recording. And finally, if you like subtitles, click the live transcript button to enable Zoom's closed captioning feature. Who is ReversingLabs, you may be asking? Protecting organizations from increasingly sophisticated cyber threats is what we do. At ReversingLabs, we leverage the world's largest threat intelligence repository to protect software development and power advanced security solutions. Our threat intelligence repository is 7 times bigger than VirusTotals, and it keeps the most advanced cybersecurity organizations and Fortune 500 enterprises informed and in front of malicious actors. Our software supply chain security and threat intelligence solutions have become essential tools for advancing enterprise cybersecurity maturity globally. ReversingLabs operations are spread throughout the US and Europe, with offices in Zagreb, Croatia, and Cambridge, Massachusetts. And our customers are in just about every corner of the globe. We have just under 300 employees, and we're looking to hire more. So if you or someone who's in the market for a new opportunity, please check out our careers page to view our current openings. The man who will be deconstructing these software packages for you is Tim Stahl, a seasoned security professional who boasts almost 20 years of experience in information security, with additional experience in information technology related to both the engineering and administration of enterprise networks. Tim has secured and defended networks across .mil, .gov, and .com enterprise domains, and his expertise includes the tracking of both APT and criminal groups, threat intelligence, threat hunting, data analysis, OSINT research, DevOps, and SIM engineering. The subject of today's software package deconstruction is Docker Desktop. Container security involves more than containers. It also encompasses the tools used to create and manage them. Today, we're going to take a look at one of the most popular container-related applications, Docker Desktop. Cyber criminals have already used malicious container images as a means to install crypto miners on enterprise networks, and that means they can also be used as part of a supply chain attack targeting cloud-native environments. The tool we'll be using to analyze Docker Desktop is the software supply chain security platform from ReversingLabs. The SSCS platform decomposes the final deployment software image, describes its underlying software behaviors to determine deployment risks, and when it finds a red flag, it prioritizes remediation guidance. SSCS is powered by the world's largest private file reputation repository, with over 10 billion files and about 8 million new files added daily. It not only helps prevent threats from reaching production, but can also find exposed secrets before release. And as a bonus, it can also generate a complete software bill of material. And with that, let's turn it over to Tim Stahl.
Hi, welcome everyone. I'm glad you guys could join. We're going to talk about Docker Desktop today. Bottom line up front, this is actually a pretty good package. We've talked a lot about, in previous episodes, we've talked a lot about the basics of doing this type of analysis from a TPRM perspective. And we do hear a lot about container security, but it's mostly targeted towards containers. And a lot of times this is that gap in our network defenses, is the tools that you use to do other things are overlooked as part of your attack surface. So we can see here from the overview, this is a fairly large package. It's over 600 megs. There's not that many issues for this size and complexity of a package with over 3,000 software components embedded in it. It's pretty good. Now, part of this, again, we've talked about this in other episodes, part of this is about tuning your policy set and creating a baseline. The next 2 episodes of this series, we're going to concentrate specifically on that and talk how to do that thing, how to set it up, how to make sure you're seeing what you need to see and reducing the noise. So we've done that here in this policy set. You'll notice that there aren't very many low detections here. Those have very little impact in your risk assessment when you're looking at these packages. So there's no point even seeing them. And we'll talk a little bit when I walk through some of these sections of things that have turned off to tune out some of the noise so you can just focus on what matters, right? So you can quickly do these assessments, do it release after release, make it part of your process and repeatable, but it's also quick and easy. Like we've talked about before, the first time through a package does take a little bit longer because you have to get a feel for it. And then after that, you're just doing the diffs. So you're just looking at the report, just the things that change between release to release. So it narrows the focus and makes this a lot more easy. But the first time through, you do want to try and get a feel for the package, what it's doing, do that assessment of the behaviors, make sure they align with what you expect. There's nothing that looks odd. And you're looking for large patterns of behavior. There's usually not one smoking gun in these things. Unless there's malware, there's usually not one thing that'll stand out and say, whoa, don't install this, right? Malware and tampering are usually the big ones. But it's large clusters of activity or subcomponents that have a lot of issues, CVEs, malware is using these things. You build that risk profile up using all these elements. And then the equation tells you whether or not you want to push this, you want to buy this, whatever. So again, not a bad package, very complex, a lot of stuff going on with this thing. So not too many issues here, which is a good sign. We have the fail policy set. But for TPRM, that's more of, hey, these are the things you need to investigate to determine whether or not this is a big issue or not. So we do have some things we want to look into. And we've talked about a lot of the basics like file rot, behaviors, diff analysis. So now we're going to start moving a little bit more into the analysis piece, right? Okay, now I've seen something bad. How do I determine whether it's really bad or not? And today we'll talk a little bit about secrets that aren't so secret. So looking through this, there's some vulnerabilities. We do see some secrets in this one. And like I've mentioned before in other packages, it's not really about the package. It's the package and what it has in it to tell these stories and explain these things. So there's nothing bad about Docker Desktop. It's actually a really nice package. They've done a good job preparing this and keeping up to date on things. So we look at the bill of materials down here. If you're doing this, whatever tool you're using will have this generate these bill of materials. You just have to make sure you're doing this at build time to get the full scope of everything, because all these dependencies, these third-party packages, this is really where your issues tend to lie. We can see here the highest priority issues and the highest counts tend to have CVEs as well. But if you look at the product names, we have Sneak has a component in here. It's not signed, but it is Sneak. The investigation showed us that's what it is. You can map that back to the GitHub project, and it's the Sneak CLI. So that's interesting. Didn't expect to see that in here, but that's fine. It does have a CVE, but it's in the dependency. And like we've seen before, hey, look, zlib, right? We've seen that before. We talked about that in other episodes. These third-party elements are where these things lie. And this is what falls through the gaps is companies that produce software are really good. If they're using a bunch of tools and they're really careful, they're great about curating their own code. It's the third-party pieces that get added and all those dependencies they drag along with them where these issues lie. If you're not doing that scan at build time, you're missing a lot of stuff. So there's some other things you look at here that sort of help depending on your tool, but you should have a lot of this stuff no matter what tool you're using. Is publishers. I like to go through the list of publishers and it gives you a sense of what's in the package. When you see usernames and freemium email stuff, those are open source packages. And you can generally use these emails and these names to then search for that package if you need to. Internet search is definitely your friend on these things. And some of these, and I don't do all of these. I won't go through and look at all of them, but I'll periodically look at a couple. So I saw this one. I thought that was a fake name because I spam in it. I was interested. I looked it up. And we can see Google searches will lead you right to the projects this person is involved in. And hey, look at that. Sneak is known to use some of their packages already. So that gives us a sort of a connection to what we've already seen in the package. It just helps paint this picture of what's actually going on. We had another one in here that was pretty good. Where is this one? This person. So this person has a lot of packages. I hope the Docker team sent this person a t-shirt or something. But this gives you a sense of what's going on inside your package. If we look at the issues tab, now, again, your tool will have this set up differently, but it's all in here. So the things you want to look at are malware. There's no malware detections, vulnerabilities, and secrets. are the big issues here. And you can see in the vulnerabilities, there are no low and mediums found. Again, that's because those are turned off in this policy set. That's just noise. Your assessment is going to be based on the high level ones. You're not going to have time to dig through all this stuff, right? If the software producer didn't have time to dig into these things, then it's probably less of a concern for you as a consumer. It's just you're inheriting someone else's tech debt, and it's just how bad does that affect you? And so the high ones are really the only ones you want to look at. So we'll look through that in a second. But the secret stands out because you generally don't see a ton of these, one or two sometimes. But there are reasons sometimes that secrets appear in these things. It's not always a leak. So we'll see that here. So presence of private keys. So let's take a look at which files have that. And if we look at this, libutils. And again, so there's several of these in here. Now, doing that analysis and digging into it, it was exposed several months ago, so it's not a new thing, and the whole file is a secret. Now, if you dig into this, and in this case, this may be a step too far for a lot of folks, but you take this file, we extracted it using a sandbox and threw it in a hex editor, and you can read through the comments in the code to tell. So all of these are actually testing keys that are embedded in here to test cryptography. So there's a bunch of different keys covering different protocols, and it uses that to validate whatever cryptography your host is using. So these are testing things, right? It's not necessarily a leak. We have one in Sneak. It's older, 8 months, lower risk on these things, but it's something to keep an eye on. This is also something you want to look at in your diff reporting to see when these are getting updated and patched. But it's a third-party component. It's really out of Docker's control. And this is just part of the downside of using open source software. It saves you a lot of time, but you inherit all these issues too. As long as you keep up on them, you're updating them, it's not quite so bad. So in here, like we saw with the CVEs, there's not a huge number of CVEs. So these things are mostly kept up to date. There's not a lot of file rot going on in here. So there wasn't anything in those keys, right? We dug through, answered why those are there. So those are legitimate secrets, and you do tend to see those things. Web access credentials is another one. You don't see that very often. So when you do, it's definitely worth looking into. And these are all related to Docker itself. You can see from the file path, it's all Docker related stuff. And if we look at the secrets, it was exposed 3 months ago, which may be the release date for this version. But we see this OAuth key, right? So Google OAuth cred. And we'll just remember the first 3 digits. So it's 994. So we'll look at the next one. 994. So we'll go through all of these. They're all the same. Now, again, this is where internet search is a really fantastic aid. It's your favorite analysis tool. You paste this into the search engine and you'll get a sense of what it is. So these are actually related to OAuth. So these are OAuth credentials. Did some reading through OAuth documentation. Not a fan, wouldn't recommend it. But this is part of how OAuth works. You have to have a user, what is it? There's a user ID or an application ID that is part of that. It's like Kerberos. There's tickets and then there's ticket granting tickets. And so it's a series of elements that have to happen. And this is part of that. You need something to identify the application before it can kick off that process. And that's what these are. So again, secrets are in here, but they're not really secrets. It's not so secrets. And when you're looking at these, even if it is a legitimate leak, then you have to rank that, what the impact is to you. Is it a secret leak that's part of the main core code of whatever that application is, or is it part of a third-party application, third-party component that's inside that, right? If it's a third-party component, it's probably less of an impact unless that thing does something serious, secure communications, file access, stuff like that. So that's a higher priority, but otherwise it's like a step secret, right? It's a secret that's related to your secrets. So this is just part of that risk profile as you start building up this scoring and figuring out, okay, at some point, maybe I don't want to put this on here. You can't always point to one smoking gun that says, hey, nope, stop, don't push this package. But it's usually painting a picture of broader risks across a bunch of different areas. And this is really how you have to do it. It doesn't really take that much time. A lot of these things really, you just throw it in Google and you'll usually get a thread to pull. So it's not too bad. So we had a couple of different kinds of secrets. Again, embedded private keys. Sneak brought one with them. It's older as well. So maybe just updating that package to the newest version will help because this is a much older package. Then you could just go, it's 8 months old. So now you can go back to the Sneak CLI project backtrack 8 months and run those to see which one is the right matching version based on the hash. And then you can see what the secret is. So sometimes they take a couple extra steps, but it's usually not too bad. Again, libutils, another one of those in here. The only one that's really worth digging into is this one related to Docker, just because it's only 3 months old. So again, you could extract the file. This is just placeholder configuration stuff, so that's not a big deal. So again, nothing really bad. The alert says secrets, but when you dig into them, sometimes it's not that critical. The plaintext creds in protocol strings, we'll look at those when we go to the networking section. So overall, we had some alerts about secrets, but looking into them, and this maybe took 45 minutes, just Google a couple of things and figure out what it was. So it's not too bad. This is repeatable. Anybody can really actually do this. So let's look. We do have some vulnerabilities here. So let's take a look at those. What we want to do is see what the source of these vulnerabilities are. Whatever tool you have should give you this breakdown. We just do it in this dropdown, which makes it easier to read. And you can see where these vulnerabilities are coming from. expat, OpenSSL, a lot of OpenSSL, libcurl, zlib. So between zlib, OpenSSL, and expat, we generally see one or two of these in most packages. Zlib is everywhere. If this ever gets hit with a critical vulnerability that's remotely accessible, it's going to make log4j look like a kid's Easter egg hunt. This is going to be a disaster. So keep an eye on this. This isn't everything, but this is one of those things that, again, we talked about before, where it just works, so it doesn't get touched. It's a third-party component. Everyone uses it. But if it doesn't break, the developers don't have a reason to go back and check it. So these things just age out over time and build up more vulnerabilities. This is a relatively new version, only has 2 vulnerabilities, so it's not too bad. But you do see a lot of really old versions in here sometimes. And those are usually dependencies of third-party elements. So it's 2 layers deep in your supply chain. If you don't have that visibility, you won't ever see these things. OpenSSL. So we see a couple of those. And that's common as well. So it's the older versions that are part of and so they bring a ton of vulnerabilities with them, right? Each one of these versions, OpenSSL, this is really old, version I. So you have a bunch of them here. So as you go through, you don't have control of this, but you have to go look through and say, okay, maybe that third-party package is an update. Maybe I update that and it has a better version. But these are just part of those risks of everyone using open source software. It's just something to be aware of. And here it's not too out of hand except for the OpenSSL, but again, we do see that a lot. There's nothing that I would go back to the vendor and say, hey, you guys need to fix this or I'm not using this product. Signatures. So these are the code signing certificates that we found inside this package. And we've talked about before, this is a good indication of file rot, where you do see signed components that are aging out. Usually you'll see a lot of packages where it's expired 1 or 2 years, maybe 3. When you get past that, then you start seeing more and more issues. The older these files get, the more CVEs they tend to pile up. As best practices move on for development, these are just a snapshot of time. So they start aging out and missing mitigations in these, and they just become more and more vulnerable over time. But if it doesn't break, it doesn't get attention, it doesn't get updated. So this is common, but this is fairly good, right? There's a couple that are older, but we always see that with Microsoft DLLs. And you can figure out where they come from, where the install path is to tell you what component that might be. And again, nothing really earth-shattering here. We have a cluster here of 100 that are 5 years old, but these are identical sets. So 2 sets. So these probably are in 2 different third-party components. You can dig into that, but there's nothing else that points to other risks that maybe you'd want to dig into this. So this isn't too bad. If there's nothing else, I'll let this go. If I do find issues elsewhere, I'll come back to this maybe and dig in a little bit, but it didn't strike any chord with me. So again, not too bad. So not a lot of file rot, which then impacts the CVEs that you see. When you get into behaviors, then you start to see, you're comparing what you expect based on what that application does in the behaviors. This is a pretty complicated application, runs virtualization, needs to be able to communicate with these containers when you're building them and testing them or whatever else. So you expect to see a lot of networking stuff. This is a virtualized element, so it's going to have its own self-contained file system. So we expect to see a lot of file-related stuff, a lot of file system access, and a lot of lower-level access to Linux utilities, files, and that kind of stuff, that lower level things. You do see that a lot depending on what the application does. If it manages hardware like a printer or something, then it's going to look for open ports, attached devices, lower level OS DLLs, that kind of thing. The same thing is here. So if we look at some of these, we'll see that the behaviors reflect what we want. So execution, 66 execution behaviors. That's a lot. We don't normally see that many, but it's in line with what we expect here. There's nothing that stands out in here, right? It can create and terminate threads, processes. It has a Python interpreter in it. We've seen that in the bill of materials. There's a Python interpreter here. Sometimes you'll see packages that have a full Python install tacked with it, which then blows up everything because Python could do anything. So then you see a bunch of behaviors that don't really apply, which makes it a mess, but it's not too bad here. So skimming through this again, right? It looks for USB devices. That's fine. SCSI. So these are all in line with what you would expect for this type of application. There's nothing that really stood out here. Yeah, references to lower level DLLs. Again, expected. It needs that kind of access to perform the functions. We look at files, you'll see the same thing. A lot of file and directory access. This is all stuff you'd expect this type of application to do. Again, there's a lot of behaviors in here, right? There's almost 80 different behaviors, which is excessive, but it's in line with what we expect for this type of package. So this just gives you a good sort of overview of what's going on, and nothing looks like, hey, that shouldn't be there. You don't go through all of them, but you skim through a little bit. Monitor does a lot of stuff because it has to maintain things. So it needs to know CPU information, can connect to raw sockets, that kind of stuff. So again, not too bad. And then the networking one we see a lot as well. But again, has to create this virtualized network. So you want to see things like this. It should be able to talk over a network, connect through other things. DNS configuration stuff, sure. It can add routes. So these are all things that it has to be able to do in order to be able to make these connections, these containers. So if you see these things show up in another application, then maybe they're a cause for concern. But in here, it aligns with expectations. FTP, sadly, FTP is used a lot still. So it's unfortunate, but it's part of what we have to live with. And then search is another one here. Again, a lot of actions. And it does query a lot of things, has access to a lot of data. It enumerates a lot of OS level stuff. But again, this is in line with what we would expect for this type of application. So if we go look at the networking stuff, let's take a look at, and let's fall back to the issues we saw back here with sensitive information, where we saw network strings. So now let's go diagnose that. We'll look for that tag, URI credentials, and we'll see all those strings here. Again, we see this a lot where sometimes these are just placeholder settings. So there's nothing in here that's an actual credential that looks bad. So another alert that you saw, but when you dig into it, it's not too bad. And it's just that easy to dig through these and figure out what's going on, and if there's any threads you need to pull. So overall, this was a really good package. The OpenSSL stuff is interesting. It's one of those things, it's just like patterns. It's like any other type of security. When you start doing these packages and you start analyzing these things, you'll see the same things pop up over and over. File rot is a big one. You'll see that in almost every package. The worse it is, the more CVEs you'll see, the more missing mitigations you'll see. So when you do see high counts of those, then you know it's going to be related to file rot. And then you just have to figure out where it is, if it's a specific package. And then as a producer, you go update that package, or as a consumer, maybe you reach out to the vendor and say, hey, you guys need to fix this. This is a real concern. But overall, good package, does a lot of stuff we expect. There was no smoking gun. There was nothing that looked really bad here. So I think the Docker team does a really nice job. So you feel safe using this. And then hopefully these examples give you a sense of what it's like to actually dig deeper and investigate so you can make this risk assessment. So I think we covered a lot and we covered it quickly, but I think that's about all I had. So do we have any questions?
Hey, Tim, I've got a question for you while we're waiting to see if anybody wants to submit their own question. On a scale of 1 to 10, with 1 being blatantly dangerous malware and 10 being super secure software. How would you rate Docker Desktop?
Probably maybe a 2 or a 3. They're taking care of the things that are within their control, right? There's not a lot of third-party packages are way out of date. Things are being updated. There's not a ton of CVEs. There's no really significant issues. There's no secret leakage. The big things that you worry about as a consumer don't exist here. So for as large and complex of a package as this is, it's a fairly impressive feat.
So you mean they're on the security scale, they're higher up. They're closer to a 10 is what you mean.
Oh, yeah, I reversed it. Yeah. So definitely at least a B+ on this thing.
Okay, very good. It doesn't look like there's any questions, but you can certainly send it to us after the webinar, and we'll show you how in just a moment. By the way, for those of you interested in analyzing your own software supply chain security profile, we've got a 14-day free trial available to you of the same software that Tim just used to analyze Docker Desktop. And Joanna will put the link into the chat right now. There's no credit card required or software to install. Just create an account and you'll get 14 days of free access to a full-blown version of our software supply chain security platform. You can use it to analyze malware and code tampering embedded in your software components, or generate an SBOM listing, all open source and third-party packages and software you're using, or leverage the platform to contextualize and prioritize alerts and threats in your software supply chain. Again, there's no charge, so please take advantage of this risk-free trial. And be sure to tune into our next episode of Software Package Deconstruction, when we're going to take a look at Deconstructing Supply Chain Analysis, Part 1, Creating a Baseline. There's a lot of noise and confusion surrounding software supply chain security. What is it? Does it really matter? How can it be operationalized? If so, what can I do? In this session, we'll talk about creating a policy baseline and tuning it to suit an enterprise's use cases, risk appetite, and areas of concern. You'll walk away from this session with a much better understanding of the main areas of supply chain security and the risk they may pose to your organization. You'll learn how creating a use case focused policy to reduce noise will help your AppSec team better focus on the things that matter. And you'll understand why policy configurations aren't one size fits all. Different teams, projects, or risk profiles may require their own custom policy set. It's definitely an episode you won't want to miss, and it airs on Thursday, July 27th. And we look forward to you joining us then. And that concludes this episode of Software Package Deconstruction. Thank you all again for attending. Please be on the lookout for announcements about future episodes from Reversing Labs. Have a great rest of the day, everyone, as well as a great rest of the week. And remember to broaden your view of software risk by securing your entire software supply chain.